Canned tuna is consumed by hundreds of millions of people globally each year. Its science is more complex than its simplicity suggests. Canned tuna is one of the most cost-effective protein sources available, and one of the most misunderstood. The canned fish category involves genuinely different nutritional and safety profiles depending on species and pack medium. 3 legitimate scientific concerns follow canned fish: omega-3 content, methylmercury, and packaging chemistry. Each of these concerns has a quantifiable answer in the science. We will work through all 3. Not all canned tuna is the same species. Skipjack and albacore have significantly different nutritional profiles.
Light canned tuna is primarily skipjack, a smaller, shorter-lived species with lower mercury accumulation.
Animation of albacore tuna at a larger, longer-lived species. Lifespan 10 to 12 years, sold as white or albacore tuna. Albacore versus skipjack presents a genuine trade-off: more omega-3 against more methylmercury per serving. The consumer decision is yours. Relevant omega-3 fatty acids in fish are DHA and EPA, the long-chain forms with established health benefits. DHA and EPA are associated with reduced cardiovascular events, brain development, and anti-inflammatory effects in research. A 2012 meta-analysis of 20 studies found 2 to 3 servings of fish weekly associated with reduced coronary heart disease risk. Canned salmon and sardines provide substantially more omega-3 per serving than canned tuna. Canned salmon delivers approximately 7 times more omega-3 per serving than canned light tuna. Tuna packed in oil retains more omega-3 than water packed. Oil prevents omega-3 leaching into the pack liquid. When water-packed tuna is drained, omega-3 content is reduced by 20 to 25% compared to oil-packed. Using the liquid from water-packed tuna in a sauce or dish recovers the otherwise discarded omega-3 content. The canning process involves heat sterilization, but omega-3 fatty acids are largely preserved through the process. DHA and EPA retention through commercial canning is typically 70 to 95%, depending on process and species. Canned mackerel provides comparable omega-3 to salmon and is often available at lower cost. Canned sardines with bones provide significant calcium in addition to omega-3, one of few non-dairy calcium sources. A serving of canned sardines with bones provides approximately 350 milligrams of calcium, equivalent to a glass of milk. Canned salmon and sardines are among the richest dietary sources of vitamin D, a nutrient deficient in many populations. Canned fish delivers complete protein, omega-3, vitamin D, and vitamin B12 in one of the most cost-efficient formats available. Mercury enters the marine food chain when inorganic mercury from natural and industrial sources converts to methylmercury. Methylmercury bioaccumulates through the food chain, concentrating in progressively larger and longer-lived fish. Methylmercury binds to sulfur-containing amino acids in protein, accumulating in muscle tissue and crossing the blood-brain barrier. Mercury concentration from ocean water to large tuna can increase by a factor of 1 million through bioaccumulation.
Albacore tuna contains approximately 2.7 times more methylmercury per gram than light tuna.
The FDA and EPA jointly issue fish consumption advisories, updated regularly as methylmercury data accumulates. For healthy adults, the FDA considers 2 to 3 servings of canned light tuna per week within safe parameters. Albacore tuna is recommended at a maximum of 1 serving per week for the general adult population. For pregnant women and young children, the FDA advises greater caution due to fetal and developing brain sensitivity. Pregnant women may consume 2 to 3 weekly servings of light tuna, albacore limited to once weekly. Children's mercury exposure is adjusted for body weight, smaller servings, and lower frequency recommended. Methylmercury readily crosses the blood-brain barrier and placenta. The fetal nervous system is particularly vulnerable. High methylmercury exposure during fetal development is associated with impaired cognitive and neurological development. FDA advisories include substantial safety margins. Occasional excess above guidelines is not a crisis for most adults. Selenium, present in high concentrations in fish, partially mitigates methylmercury toxicity by forming inert compounds. Fish with favorable selenium to mercury ratios, including salmon and sardines, present lower effective methylmercury risk.
Large tuna species show near-neutral selenium to mercury ratios, reducing the selenium buffering effect on mercury toxicity.
Mercury levels in canned tuna show significant variability within the same species. Testing by Consumer Reports documents this. Mercury content varies considerably between individual cans of the same product. Population averages mask this range. Mercury risk from canned tuna is real but manageable. The key variable is frequency and species choice. Rotating across species, light tuna, salmon, sardines, mackerel reduces mercury exposure while maintaining omega-3 intake. Sardines and salmon provide omega-3 at a fraction of the mercury exposure of albacore tuna. A 3-species weekly rotation maximizes omega-3 intake while minimizing mercury accumulation across all servings. Industrial coal combustion remains the primary anthropogenic source of mercury entering marine ecosystems globally. Ocean methylmercury levels have approximately tripled since industrialization, making fish species selection increasingly relevant. Canned food chemistry involves the metal, but more importantly, the interior lining that separates food from metal. Bisphenol A, or BPA, was the standard interior can lining material for most of the 20th century. BPA mimics estradiol structurally, allowing it to bind to estrogen receptors in human cells. BPA's ability to activate estrogen receptors raised concerns about reproductive, developmental, and metabolic effects. BPA migrates from can linings into food. The sterilization heat used in canning accelerates this migration. The FDA has reviewed BPA in food contact materials multiple times, with evolving conclusions as research accumulates. The FDA's current position is that BPA exposure from food contact is below levels expected to cause harm. Some toxicologists argue FDA thresholds underestimate BPA risk due to nonlinear dose-response effects at low doses. The EU has adopted a more precautionary approach to BPA in food contact materials than the US FDA. The EU banned BPA in baby bottles in 2011 and has progressively restricted its use in food packaging. Animation of the industry transition away from BPA. BPA-free can linings, oleoresin, acrylic, polyester-based alternatives. BPA-free linings often use bisphenol S or bisphenol F, which may share some endocrine-disrupting properties with BPA. BPA-free labeling does not guarantee endocrine safety. Replacement bisphenols remain under active toxicological study. Glass-packed canned fish eliminates lining chemistry entirely, an option for those prioritizing packaging safety. Foil pouch tuna uses different packaging chemistry than canned, though pouch lining materials vary by manufacturer. Fresh and frozen fish avoid canned packaging entirely, the nutritional benchmark for comparison. BPA is detected in urine samples of over 90% of the U.S. population, indicating widespread low-level exposure. Canned food is one of multiple BPA sources in the modern environment. Total exposure is a cumulative consideration. For those concerned about packaging chemistry, glass-packed or pouch options reduce canned lining exposure when accessible. For most adults, the omega-3 and nutritional benefits of canned fish substantially outweigh current BPA exposure estimates. With the science established, we turn to practical strategies for maximizing benefit while managing the documented risks. For maximum omega-3 with minimum mercury, canned salmon and sardines are the optimal choices. Rinsing water-packed canned tuna before use reduces sodium content by approximately 20 to 30%. No salt-added canned fish varieties provide identical omega-3 and protein with substantially lower sodium. Canned fish integrates easily into salads, grain bowls, pasta, and quick meals, requiring minimal preparation. Canned salmon produces high-protein patties comparable to fresh salmon at a fraction of the cost. Dietitians consistently recommend canned fish as one of the most accessible omega-3 and protein sources available. Canned sardines provide omega-3 at a lower cost per gram than most fish oil supplements. 2 to 3 weekly servings of lower mercury species, light tuna, sardines, salmon, is a sustainable and safe pattern. Pregnant consumers benefit from tracking species and servings weekly. FDA provides free interactive guidance tools. Replacing deli meat with canned fish in lunches upgrades protein quality and adds omega-3 with lower sodium. Canned fish provides complete protein at $2 to $4 per serving, among the most affordable animal protein sources. A 4-species rotation across the week optimizes omega-3 intake while minimizing mercury accumulation. Sardines on whole grain toast with mustard and lemon is a 2-minute meal delivering exceptional nutritional value. Canned fish delivers complete protein, omega-3, vitamin D, and calcium in one of the most affordable food formats. Mercury exposure is determined by species, not by whether fish is canned or fresh. Species selection is the key variable. Most canned fish now uses BPA-free lining, though replacement materials warrant continued toxicological monitoring. Sardines and salmon outperform canned tuna on both omega-3 content and mercury safety, the underutilized option. Species first. Rotate varieties. Rinse for sodium. Include the liquid for omega-3. Simple, evidence-based choices. Canned fish has one of the most favorable nutrition-to-cost ratios in the grocery store. The science supports it.